Hey everyone, in this video I want to provide an overview of Azure Data Explorer, or ADX. This phenomenal service to enable me to ingest huge amounts of data and then actually get great insight from that data using KQL. As always, this is useful. A like, subscribe is appreciated. So let's take a step back. So I mentioned the word lots of data and getting insight from that data. So the reality is, in most companies today, we do have a huge amount of data. Now, this data could be logs. These could be logs from applications or operating systems. Typically, a time and some kind of description of an event that's happening. These could be metrics. These metrics could be CPU percentage, a temperature, many other types of things. It could be telemetry. I might have the idea of, well, I've got a coordinate and then I've got some value from those coordinates at different moments in times. But just this huge amount of data coming in. Could be from computers, could be related to people events like authentications, could be IoT sensors, just vast numbers of sources for all these different types of data. And ultimately, we tend not to really care about the data as such. What we really care about, if we really think about it, is I want insight. Now, that insight is for many, many reasons. I might think about, well, I want to get some kind of insight for planning. I might want to understand, well, why did this happen? I might want to understand predictive what's going to happen. So it's giving me information so that, I can make decisions or at least understand something. It could also be, I want to do some kind of alerting based on these combinations of different metrics and signals coming in. Maybe there's a hint of danger. Maybe it's a sign of imminent failure, and I want to be able to alert on that. So I want to be able to do these things. Now, if I think about getting insight from this data, and sure, I may also just want to store it for forensic purposes, potentially. What gets me from sources of data to be able to actually get that insight? Well, the first thing I have to be able to obviously do is I have to be able to ingest it. I have to be able to get the data from those source systems and realize if we think about these huge range of sources, well, that format's going to be different. Some might be JSON, some might be XML, some might be structured, some might be unstructured, just like text. Some might send it over certain APIs, some might write it to a blob, some might write it to an event hub, some might stream it over IoT. So we have to have some method to ingest the data, to be able to talk to all these different sources. Once we ingest it, well, I have to ingest it into something. So I then have to be able to store it. So we need some kind of store. But if we think about all these different types, it has to be flexible because I might have very structured data, i.e. there's a fixed schema to it. Could be that semi-structured, well, the XML, the JSONs, all those different options. Or it's just this unstructured stuff. And I can't just store it because the whole point is I want to be able to do something with it. What I want to be able to do, I want to be able to perform analysis. Because it's that analysis that gets me that insight, which is the thing I actually care about. So I need a way to actually interact. I want to be able to get aggregations on that data, anomaly detection, maybe even machine learning based predictions. And as you kind of guess as I'm setting this up, this is obviously ADX. So if I think about Azure Data Explorer, it provides this complete flow, a way to get the data in, a storage for the data, and then actually get that analysis against it. And when I think about, well, what does ADX bring? When I think about that ingestion of the data, it supports both batch And that's generally the preferred option here. So with batch, I can get huge ingestion throughput. I really can think terabytes in minutes, but I can also do streaming. So maybe batch is just an option. Maybe I need near real-time prediction, alarming based on the data coming in. So I can use that. Think of Event Hub or IoT Hub. It's going to be typically smaller sets of data, but again, I can get that really, really small latency. And then once we have the data ingested with Azure Data Explorer, it provides a huge number of different ways I can actually go and interact with the data. We're going to talk about that. But there's a full web-based Azure Data Explorer to go and interact with it. There's a desktop tool. There's SDKs. There's APIs. I can integrate with machine learning. And this really is focused just on this huge analysis at scale. Think petabytes of data results, possibly sub-second, which is crazy to think about. One of the examples when I was talking to the product group about this, it was 9 exabytes of data existing in some of these environments. 108 petabytes per day is ingested in. So it's just staggering the scale when you think about this solution. Now, how do I get this insight? It's KQL. And I did a video on KQL a couple of weeks ago. So I'm not going to go into that in this video. But for this analysis, I'm using this Kusto query language. And it's this very, very friendly language. There's great tools to leverage it. But it gives me that ability to get that insight, which is really what we care about. We want that insight. And it really is aimed for interactive analysis. When I have this huge velocity, these diverse sources, ADX and KQL really do shine. Now, I want to take a little bit of a step back for the types of data, because obviously there's many other data services in Azure. There's relational databases, there's data warehouse, so where does this fit? I really think of this as when I have some time series analytics is the primary focus. Now, I can technically have tables without a time element to them, but generally they're going to have an ingestion time added to them anyway. But I really think about things that is some kind of time series data. Metrics, a value at a time. Logs, some text at a time. Some telemetry, maybe coordinates and a event at a certain time. It's phenomenal for that time series based analytics, but realize it is a relational database. If you go and look at the list of database engines, and just for a little bit of fun, we look at the data about Azure Data Explorer, well, as it shows, it is a relational database. So that relational database means it comes with all of the relational operators, the algebra that we think of with a relational database. But it is also a spatial DBMS. I can think about things with coordinates, for example. But this time series DBMS is really where it shines. Now, you may say, well, why can't I just use it as a regular relational database? And again, you can put things in here that is not time-based. But the key point here, there are no transactional guarantees, which is huge. The lack of transactional guarantee is what enables it to get these huge throughput, these huge ingestion performance, these very powerful query speeds, is because there's no transactional guarantee. And that's really the key difference between this and a more traditional relational database, where I want that transactional guarantee when I'm performing these operations. So it is not an operational database. I wouldn't think of this as constantly read and writing particular records. I would look at SQL or Postgres or MySQL or Cosmos DB. It's not a data warehouse. Hey, look at Synapse. It's not an ETL, an extract, transform, load solution. If I have some long-running task, if it's a machine model training, hey, there's things like Spark, there's things like Batch. There are better solutions for this. This is really, really shining when I think of analyzing log and telemetry at just huge scales. Hey, I'm writing my application, I've got some solution, and I'm going to be emitting these massive amounts. So I need to collect in from lots of different sources and then get that analysis against it. This is where Azure Data Explorer shines. I think about it's really append data only. I'm not going to modify really existing records. I'm appending data only. Now, with all that said though, when I think about this data, and I've mentioned this already, sort of some of the, well, what is this data coming in? What's really powerful here is it can be structured. So I can think about, there's that idea of a fixed schema. I have these various columns, these attributes of the data of very specific types. So a fixed schema, it's great at handling that data. But it can also be semi-structured, self-describing, a JSON file, an XML file. And it actually has a special dynamic data type that's fantastic for handling that. But it will then give me insight into the content of that semi-structured data. And I showed this in the KQL video I did. But it doesn't just treat this as, okay, there's a text string over there. I don't really know anything about that. It has a lot of powerful operators and it does some special indexing, some special optimization to then enable me to go and interact with that semi-structured data. But it also supports unstructured, i.e. just a text string. And even here, as it's doing those ingestions, it does optimizations, it adds special indexes. And I can do many operations, even on unstructured. So I can think about, well, there's a has operator. So I can go and find out, well, does it have this certain content within it? I can perform very complex interactions and extractions using extract. And extract lets me run regex expressions. Everyone loves regex, but I can run regex expressions. There's even a parse operator that really simplifies regex. So as it ingests this unstructured data, it's doing some clever things behind the scenes to optimize indexing. Then it's got a lot of great operators to go and interact. So it has special provisions for semi-structured and unstructured so that I still get a fantastic ability to then actually go and analyze the data. So as it's ingesting and storing, it's doing extra work to optimize, to index those semi-structured, those unstructured sets of data. Okay, so we want to use it. We're like, yeah, this sounds like the solution we want. Well, what do I do? How do I start using ADX? So step one is we create a cluster. And I guess what might be a good way is to just show you the starting kind of screen from this. Now, I can create this from the Azure portal, but there's also this idea of the Azure Data Explorer environment. So this is a web-based GUI, and again, I talked about there is also a desktop application. So there's this whole set of capabilities around here. So I've got my little free database, and I'm going to talk about that later on as well. You can see, hey, here's my home over here. But for right now, I can just, in the Azure portal, if I search for Azure Data Explorer cluster, I can just say create. Now, obviously, I select a region, just like many other Azure resources, I give it a name. The first thing I select here is there is a workload type. So we see here, we get this option of dev test, storage optimized, and compute optimized. And these modify some of the types of SKU we can use to actually power our cluster. And it also impacts the scale. And I'm going to come back to that. Today, I'm just going to pick compute optimized. Notice then we get different sizes available to us. I could select other, we have availability zones, so I'm just going to pick one. Notice it's showing us the VM SKU that it's using behind the scenes. And notice we do have AZ support options here. So as I create the cluster, one of the options we have here is about what is the zone redundancy we want. And I have to set that when I create the cluster. So at cluster creation time, I can say, hey, I want to pin it to a particular zone, Or I can say, hey, I want it over these zones. If I pick all 3 availability zones we see in our subscription, remember availability zones have independent power, cooling, networking. So I get resiliency from any kind of node or even data center or supply, like, hey, a substation failure. I have to pick that when I create the cluster. So I think about, okay, I'm going to create my cluster. Ooh, that's weird. What's going on here? Delete that. Okay. So I have to create my cluster. And my cluster actually comprises of a few things. Behind the scenes, it's creating a dedicated virtual network. I don't see that, but it's going to go and deploy it into its own virtual network. I have that zone redundancy option. But there are actually 2 different parts to the cluster. And we would actually see it if we looked at the pricing calculator. So if I go and look at the pricing calculator for a second. So I've already opened up Azure Data Explorer here on the pricing cluster. And you notice we give it certain pieces of information, data collected per day, my hot cache retention. I'm going to talk more about this, my total retention, estimated data compression. But the key point I want to look at really is, hey, look, there's data management instances, and these look little. Oh, a D1V2. I mean, that's a really tiny little virtual machine, and there's 2 of them. And then there's engine instances. Okay, well, these are much bigger virtual machines, and it's currently set to 2. So we have these options for this data management and these engine instances. So what's this all about? So the key point here is I have to think about that whole pipeline of ingestion and then the storage and then actually running the analysis against it. So first of all, the data management, I don't really get any say into the SKUs or the sizing of that. So if I go back for a second, we think about the 2 parts to my cluster. So the first part is this data management. And typically we're just going to see 2 instances, and they're going to be small because this is not really doing a huge amount of work. So this is really focused on the idea of creating ingestion commands that the engine will then go and process and actually then go and read in the data. So this is there to really go and understand, hey, what are the ingestion things I want to do? It's going to go and handle things like, hey, if I have to batch data together, it will close off batches and then create the commands to actually go and bring in the data. So I have really no scaling or configuration control over this. If we go and look again at the portal when I'm doing this, when I'm picking these options, when I'm picking this workload, these are all the engine. This is nothing about that data management cluster. I don't get any say in it whatsoever. So the data management cluster is this down here. And notice it's just really hard coding it to 2 nodes, which is its standard. It will scale if need be, but it's really not doing a huge amount of work. So it's just saying, hey, 2 nodes, whereas the engine instances, this is what I get more configuration on because it's the engine that's actually going to bring in the data. It's the engine that actually runs my queries for me. But there is this second data management cluster behind the scenes that's really going and creating the commands that the engine has to follow to actually bring in the data. So we don't really get any say in it, but there is this data management cluster. But then, more interestingly, we get the engine. We get this engine cluster. We'll draw this bigger. Now the engine cluster can have many more. So it has a minimum of 2 nodes up to 1,000 nodes. Now there is an exception to this. I can have a 1-node cluster if I pick dev test. So if I went back and looked for a second, and I want to go and create my cluster, if I do this compute optimize, and let's just give it a name, test, and did scale, 2 is my minimum count, but I could set a maximum count. But if I was to change this to dev test, now it's just 1. Dev test, again, it's not designed for actually doing any large scale. It's for me to experiment with. So I want to do this kind of as cheaply as possible. Hey, pick dev test. Well, I'll correct this. This is not the cheapest possible. At the end, I'll show you ways to do this for free. But in a actual real cluster that I'm creating as an Azure resource, dev test just gives me this single node. It's the cheapest option that I can do. And again, it's just manual scale. But if I pick any of the other 2 options, storage optimized or compute, then, hey, I go and pick what I want to do. And then it's showing me the compute specification. So it's just VM SKUs behind the scenes for this. So I could select others depending on exactly what I'm trying to do here. And then again, my scale, hey, I can configure this. And again, I think I should go all the way up to 1,000. Yep. So we try 1,001. Yep, can't do it. So 1,000 is the most. You might guess at what it's using behind the scenes then, because something else has a maximum of 1,000. So this is all related to the engine. This is that configuration of my database engine. So this is going to scale whatever I need it to do. Now, those nodes are doing more than just acting as a brain. It's more than just running the queries. It's actually part of the all-up storage solution as well. Because if we think about a virtual machine, if we think about many data solutions, well, often we have the idea of kind of a cold storage area and then a cache area. And that's where this comes into play. So the nodes, they're also being used as the cache. So there's an SSD layer, and I'm drawing it on the outside of the nodes because how this is implemented actually varies. So the nodes are providing the hot cache using SSD storage and also areas of its memory, but the nature of the SSD varies. The SSD is provided by the temporary storage if I'm using the compute optimized workload specification. But it will actually use managed disks if I'm using the storage optimized. So it varies how it provides that SSD storage depending on the SKU I select, that workload. And if it uses managed disks, it's going to attach between 1 and 4 premium SSDs to each of the nodes. So each of the nodes has this amount of SSD storage that it then uses for the hot cache. And obviously, the hot cache is far more performant when I'm running queries against it. And it's really these configuration options around the cache that's going to drive the number of nodes you have. Because if you think about it, it's the nodes that are providing the cache. So if I, as part of my configuration, say I need 30 terabytes of hot cache, for example, and each node has a certain amount of SSD, well, if each node had 1 terabyte of SSD and my configuration drove me to need 30 terabytes, well, I need 30 nodes to provide sufficient hot cache. So when I think about nodes and scaling, it does auto scale. So I can manually scale, I can turn on auto scale, but the number of nodes is really going to be driven by how much data I need to keep in the cache, but also the number of concurrent queries I want to run against it. Because remember, the engines are really doing two things. It's part of the actual storage of its hot cache. And then when I run a query against it, it's the engines that have to do the work. So the number of nodes I need is really a factor of how much hot cache do I want and how many concurrent queries am I actually going to be running. So that's a really big thing to consider. I can actually stop and start the compute side. So I could stop the compute and I can stop paying for it. It will actually deprovision the VMs and disattach to it. That part just goes away. It can auto pause. I can optimize the auto scaling based on the cache, based on the CPU consumption. It has a prescriptive auto scale. So based on history, based on that historic seasonality it sees, it can pre-scale ahead of time. So it's seen historically, hey, maybe a Friday afternoon, there's more concurrent queries. It will pre-scale before those queries come in. So it's ready, so it can give you the performance you need rather than, oh, my CPU is spiking, I need to go and add some nodes, which would have a performance impact on the system. Now, when I think about the pricing, really what I'm paying for are just the basic VM SKUs. Well, then who pays the salaries of the poor ADX team that actually has to develop this stuff? So you will notice in the pricing calculator, because so far, all of this Data Explorer cluster is just VM SKUs, and you just pay the regular VM price. But in addition to whatever these engine sizes are, the data management instance sizes are, there's an Azure Data Explorer markup. So for each core, there is a per hour per core markup. And this is what basically pays for Azure Data Explorer, intellectual property, the investments, the work that's done to create this service. So for the most part, you're just paying for the regular Azure Data resources, but then to actually pay for Azure Data Explorer, the service that runs on top of these just regular Azure VMs, that's what that markup is for. That's what pays for the development of the Azure Data Explorer. So that's part of the pricing. The rest of it, hey, it's just the regular virtual machines. Now, additionally, so I've got these two clusters. Again, the data management is typically just going to be two very, very small virtual machines. And then we have the engine. It's running on its own virtual network. So to communicate with this, we do have load balancers. So obviously these do sit on the network. I do have to be able to talk to it. So there's a load balancer, there's a DNS name to actually go and communicate to this service. So you'll see one for the data management, one for the query endpoint. And I mentioned the idea that I can stop the compute. And I mentioned the idea that there's the hot tier, the cache, and then there's the cold storage. Okay, so where's the cold storage in this picture? So the engine also communicates with blob. So it's just using regular old blob as part of this. So we also have Azure Storage. So this is just regular old and Azure Storage. It's using blob, and it is the regular blob hot tier. So regular general purpose V2 storage accounts have hot, core, and archive tiers. This is using the hot tier of blob. I don't see these. It automatically creates these as it needs to. And obviously I have to pay for this. So I pay for Azure Blob Storage. But one of the really nice things about this is it does huge compression. And typically, it's typically a factor of 7. Which you saw in that pricing calculator. So if I was to ingest 1 terabyte of data, it actually only stores 140 gigabytes of data on the blob. So it's doing this compressed column store. So on the actual blob, it's compressed column store data. Because if you looked at data, column store is very effective when we want to do things like aggregations and interactions with various types of data. So that's what it's using behind the scenes. And at a table level, I can specify if I want this hot or cold storage. When I query, ideally, I want to be pulling from the hot cache. That's going to be far more performant. If I actually have to go and pull it from the cold storage, then obviously that's going to be slower. Now, when it does have to go and pull from Blob, it will then cache that data. So if there's a second query against it, hey, it's going to be available. I'm going to get a better performance. But I get a lot of control about that. I need to understand what are the types of analysis I'm going to be performing. When I go and create, for example, databases, I can say, well, how many days of data do I want to keep? I have those controls of when I do those interactions. So, hey, this table, I want 7 days in the hot cache. I want to keep 30 days. So I get to pick how do I actually want to do that as part of those creations. And I'll talk about that in a second. So if I do have to access cold data, I really want to be very, very specific in how those queries are running. I want to do a point query. So very specific. I want to limit the amount of data I have to pull because I will see a very, very different performance. It is partitioning the data into shards. That's really the way that it can get these huge ingestion performance. Typically, it breaks it and partitions it into shards of maybe a few million records. It then encodes them, it indexes them all independently to enable me to get that performance. I mentioned already, all data is actually processed by the engine. And it does give that special attention as the data is ingested, as it's brought in to that semi-structured, to that unstructured data, to give it that better encoding, to give it those extra indexes so that when I do want to query against it, I get that better performance. If you use log analytics, there is no concept of analytical or basic or archive type logs here. That's a log analytics specific feature. That's nothing to do with Azure Data Explorer itself. So we have these clusters. We start to understand some of the configurations we're going to do later on when we understand, hey, that hot cache is provided by the nodes. The nodes have a finite amount of SSD based on that type of compute optimized, storage optimized. And so the amount of cache I specify is going to result in the nodes having to scale out to meet that amount of cache. And also, hey, the concurrent queries I'm running against it. Now I drew the idea of these load balancers. So that's the endpoint through which I use to communicate to my cluster. And there's different options for this. So the default for these endpoints will just be public. So my default type here is going to be a public endpoint. And that is actually the majority of deployments, just use a public endpoint. I can limit it to specific IPs are allowed to communicate, just like many other services in that firewall. I can say, hey, only these IPs are allowed to connect. There's also a VNet injection option, but that honestly is not really recommended anymore because my other option, and this has really taken over, is I can do private endpoint. Like many other Azure services we see today, now what I can have is, well, I have my virtual network and I can create private endpoint, and the private endpoints will go to a specific instance. Now, the reality here is it's not one private endpoint because there's at least two, because there's two different load balancers for the two different clusters. But then there's also private endpoints to, well, there's a whole set of storage. There's transient storage accounts used for many, many different things. So the reality is there's actually 8 private endpoints that I have to set up for a particular Azure Data Explorer cluster. One for the data management, one for the engine, and then 6 for the various transient storage accounts. So if I think about, okay, if I want to dedicate a subnet just for these private endpoints, how big would it have to be? Well, I need 8 for the private endpoints. I always lose 5 for just any subnet in an Azure virtual network. The all zeros, the all ones, the gateway, and 2 for DNS. That's another 5. So I need 13, at least the size of a 13. So it's going to be a /28. /28 is the minimum size I could ever have if I just did want to use a dedicated subnet for the private endpoints. Once I enable private endpoint, if I wanted to, I could now go and completely disable the public endpoint. So now I could only access it through this. Now, as I did mention, it does have its own dedicated virtual network. On that dedicated virtual network, if I want to, because remember, it's going to be ingesting data from other services, I can create managed private endpoints to other services. So hey, I've got my event hub, for example, or I've got Blob. I can create private endpoints in this managed virtual network that ADX uses to other services I might have, so that ADX can go and communicate to my other services using private endpoints so they don't have to be exposed to the public. So I can create managed private endpoints to other services I might have. I can restrict outbound. So if I'm worried about data exfiltration and, hey, talking to some other rogue storage account so I can copy data to it, there are call-out policies that I can define in my ADX cluster that restricts what am I allowed to talk to. That could just be fully qualified domain names, or I can use regex expressions to define, hey, this is what I'm allowed to talk to. So if we looked at documentation super quickly, it talks about, hey, restricting outbound data access from my cluster. And it talks about, hey, look, I can create these basically regex expressions on what I'm allowed to talk to. So I basically define, hey, it has to match within this specification to be able to talk to it. And I can also specify just direct fully qualified domain names. So I have those 2 options to restrict that outbound communication. So if I need to do that, that's absolutely available to me. So I have a lot of control over the networking side, both, hey, talking to the Azure Data Explorer, allowing Azure Data Explorer to talk outbound, but also, hey, there's managed private endpoints to talk to other data services that I might have. Now, once I have the cluster, well, I have to create a database. And those databases will use the available resources. So I've got my cluster. The next step would be to create one or more databases. So on top of the cluster, I create N databases. And there's 2 key values that I'm going to specify if it's a regular type of cluster. If I do the free cluster, I won't see this because I don't have all these cache and other options, but I'm going to pick the amount of cache and I'm going to pick the retention. And this is important because remember, this is going to use the underlying resources of the engine. So if I pick a certain value for the cache, well, that's going to be kept in the local SSD of the nodes. So that's going to drive how many nodes I need, which is going to drive my cost, because that's going to be a big factor to make sure I have sufficient hot cache. For example, if I said, hey, I want 30 days of data in the hot cache, and it's 1 terabyte a day, I need 30 terabytes of hot cache. So again, depending on how much cache I have per node, it's going to have to scale that accordingly. So that's a big factor. If most queries were just based on the last week of data, then hey, I just need to set my cache to 7 days. So I have those options. So this is going to be an impact on the cost. So I really do want to understand how are people really going to interact with this data to make sure I drive the right options when I actually do this. So, and again, I can create multiple databases. They share the underlying set of resources underneath. If I looked at my environment, so I just have a free cluster over here, then I don't get all of those same options. So let's close this down. If I was in my Azure Data Explorer, I've already got my little free cluster. I can create a database, but I just give it a name. Because in the free cluster, I have no control over really the engine or anything else. But if I was in the regular Azure Data Explorer environment, I create a database, it would also ask me, hey, what is the retention you want? And what is the caching I want to, hey, that interactive amount of data would drive that. So I would get those options available. And then obviously within the database, I would then create tables to actually store my data. So to actually get the data, I have to ingest it. So how do I actually get the data in? And this is where the data manager comes into play. See, if I think back to that idea of, okay, I have my data. I need to ingest it. Now, the data manager is going to perform the initial validation of the data. It might do potential, it's going to work out the commands to then bring it into the engine. So that's really the important part of what's going to happen as part of this. Now, what am I ingesting from? Well, there's something called managed ingestion pipelines. So for example, this is going to work for things like Event Hub. This is going to work for IoT Hub, Event Grid. But I can also go and get ingestion from things like Azure Data Factory. Azure Data Factory is very tightly integrated. There are SDKs. There are connectors. There are wizards that can drive the ingestion. And then there's actually ingestion commands, which are ultimately what the engine performs. So if I use ingestion commands, it actually goes directly to the engine. It doesn't go via the data management cluster. Those go directly in. The SDKs, hey, .NET, Go, Java, Node, REST, Python. The connectors, there's plugin from Logstash, Kafka, Power Automate, Apache Spark. There's a huge number of formats supported. So if we go and look at all the data formats supported for ingestion, I mean, there's just a crazy number. Avro is super popular. JSON, multi-JSON, awk, Parquet, PSV, RAW, TSV, text. It can have data compressed, gzip, zip. If we think about those data ingestion properties, there's different things I can configure as part of the ingestion. Then there's even a nice little picture showing, hey, look, this is the process of what happens during that data ingestion process. So we have all of these things. So the whole point is data management prepares the ingestion commands and writes them out to a queue. And the engine then reads them from the queue and does the actual data ingestion. So if we think about these interactions, if the data is coming in and it's batch data, well, the batch is actually going via the data management cluster. And then what the data management cluster does, it's responsible for creating those batches, for sealing the batch. By default, I think it's 5 minutes or 1 gigabyte of data or 1,000 blobs, but I can adjust it. I can set the batching policy to say, when does it close off this batch? And then once it creates those batches, it creates the commands, the ingestion commands required, which it writes to a queue, which the engine then goes and processes. So it's the engine that does the actual ingestion of the data. The data ingestion does not go via data management. All data management does is, hey, it will close off the batch, it will work out the command to do the ingestion, and then tell the engine to actually ingest the data. So that's why the data management can be so small. It's really not doing a huge amount. It's really just there to create the commands, to do some initial validation, and then tell the engine, hey, go and talk to the sources, maybe the blob, read in the data, and it's this that will then actually store it into this compressed column store. That's where there's going to be maybe some small latency introduced. Now, if I'm streaming the data, because it does support both batch and streaming, well, if it's stream, it goes direct to the engine. There's no point going via data management if it's streaming data. So if it's streaming, it is going to go directly to the engine. And we can see the detail of the ingestion methods and what's available. So for example, if I use the ingestion wizard, it's batching. It tells you, hey, it's batching to container, whatever. The light ingest, hey, it's batching. Or can go to the engine. If it's Kafka, hey, it can batch or stream. Apache Spark is batching only. But it tells you, hey, is it batch? IoT Hub could do both batching and streaming. So it gives us information on the supported formats, the supported sources for the various ingestions we're actually going to have. And we can see this. So if I look at this is one of the tools, Azure Data Explorer. I've got my cluster over here. I don't want to create a new database. And it's actually, this data hub is very, very powerful. So this is just part of Azure Data Explorer. And notice it's giving me, hey, I can ingest data from files, from blobs, from blob containers, from Event Hub, ADX Gen 2, iData Lake, table, batching, policy, because I can control all of these things. If I was to say, hey, I want to create a table, for example, and let's actually do it from my ADX. So I've already got my database. I can create a new table, and maybe I say it's heroes, just messing around. What's my source? Okay, well, my source here, maybe I've got a JSON file. So I can drag in my JSON file. And then it's going to work out, well, what's the schema? Now notice that my source also could have been a blob container, ADX Gen 2, the data lake, Event Hub, if I had it configured. It's now going to look at the file, and it's worked out. Hey, look, it was a first name property, a last name, code name. Now address, it's put as dynamic because within the field itself, I've got more embedded JSON. So it's just saying, hey, it's this dynamic bag of self-describing data, so semi-structured. Because it's only looking at one nested level. But to show you how smart this is, if I increase it to 2 nested levels, it's now actually broke out the address and the address country as separate columns. Because now it's looking inside to an additional level. So within that dynamic bag, it's now breaking it down into its value. So I can set, as part of the ingestion, how I want it to treat that. And then I can say, hey, start ingestion. And now it's going and reading that. It's showing me the data that is now ingested in. And now that's there. I can now run my Kusto queries against it. And there's my data. So it's really powerful how I can actually do that. And that was obviously a super simple example with my nice free little cluster. But it gives you some insight into, hey, what I can really do with this. Now, if I am streaming, the data manager again is not involved. Really, the recommendation is 4 gigabytes of data per hour max. It's just not, it's nowhere close as performant to doing that batching, which is why the batching really is the recommended approach. But again, there are many tools that I can use for this. We have this nice web interface that I can leverage. There is a desktop Kusto.Explorer application. There is a Kusto CLI there are many types of data and interactions available to me. So once I've got the data in, obviously I want to do that analysis to get the insight from it. And that's the KQL, and there's different ways I can do it. My app, Power BI, whatever I want, I can go and then talk to this data. Now there might be times that I have data not within my ADX instance, but I still want to use it as part of a query. So one of the things I can do here is I can absolutely have the idea of external tables. So what it's going to do now is if my data is sitting in a blob, ADLS Gen 2, a data lake, or it can even be in SQL, I can define that as an external table. So now I can treat that, again, it might be a Parquet file, for example. Think Polybase is really what this is acting like in a traditional data. I'm now going to go and expose this data to my engine so I can run queries against it. And those same formats I can use for ingestion, I can use as part of that external table. Now, obviously, again, there's going to be a performance implication with this. While it might be column store formats, you might be saying, well, hey, if this is blob and this is blob, and you can do queries against this. Remember, I did say, if I have to go and access the cold store for queries, it's going to be slower than if it's in the hot cache. But remember, this compressed column store that it creates, it actually does special encoding. It adds indexes to that data for its purposes to accelerate the performance when I have to run a query against it. That will not exist even if it's in a Parquet format, for example, over here. It won't have those indexes. So even if it's on blob, whatever that is, it will not be as performant as when it's running against this because it doesn't have those additional indexes that ADX adds to its cold storage. But hey, I can do that, which saves me maybe having to ingest it into ADX. Maybe that performance little penalty is not such a big deal. I can do things like a continuous export. I can go the other way. So if you think about, hey, the data is being ingested, it's coming in. As it's being read in, it stores it in the cache and then persists it to that storage blob. It could also be sending it somewhere else. It's Azure AD authentication only. It supports managed identity to then go and talk to other data sources. So this has a lot of fantastic options when I think about the security, the integration with my other services. Now, you want to play with this thing. I showed you in the portal, obviously you can go and just create a cluster. So if I wanted to create one over here, then your cheapest is DevTest. It's doing this. Notice it's extra small. There's just one instance. If we looked at the pricing calculator, if I changed it from environment to DevTest, it gets a lot cheaper because now there's only one instance for data management. See, it's one node instead of the normal two. And my engine, it lets me just have one, and it's only one. So it's the smallest, it's just one of each, one data management and one engine instance. But ordinarily, it's probably going to be production. And if it's production, hey, I can get to pick. Is it compute optimized? Is it heavy compute? Is it storage optimized? And that will drive, notice here it says premium managed disks. So if I do storage optimized, it uses those premium managed disks I talked about. If I do compute optimized, it's not using premium managed disks. It uses the temporary storage of those virtual machines. And the documentation goes through details on exactly what it does and how many it's using for the specifics of those different SKUs. But hey, I could pick that dev test if I was trying to be cheap, but I can be even cheaper. So I can start for free. I can create a free Azure Data Explorer cluster. Now, obviously, when I do the free one, I don't get those configurations of SKUs and amounts of SSD, and there's certain limits to the size of it, obviously, because it is free. But I exactly as I was demoing here, I'm doing this in my free cluster. Once you've created it, and if you like it, hey, you can upgrade to make it a full Azure cluster. So at that point, then I would pick the SKUs and I start paying for this. But I get this completely free option available to me if I want. It then talks about how I can upgrade. And obviously there are significant limits on this, right, because it's free. Another option is if I'm more interested in the Kusto side, well, there's actually an Azure Data Explorer Kusto emulator. This is a Windows Docker image. So then I just run this on my local machine so I can be completely offline. And this actually does a nice job of showing you those limits. So if we talk about the free cluster, it talks about the limits that are there. And then it talks about the limits of the Kusto emulator, this Windows container. Now, a key thing to understand though is this Kusto emulator, this Docker image, is the engine. It's only that bit. There is no data management at all with that container. So I can't do any of those types of ingestions here. All I can run is ingestion commands, because remember, ingestion commands go directly against the engine. But depending on what I'm trying to do, there's different options. For most people, if you want to just start playing with it, I would use the free ADX cluster, because then it is the full set of capabilities, and I can test out various different things against it. It's online. I can try out the different APIs. I have all of that sort of goodness available. And realize, I think it's saying that 99% or more of Microsoft services run on top of Azure Data Explorer. If you think about Bing and Xbox and Office and Azure and Skype and LinkedIn, they all run on this. And it wasn't because, hey, they had to, it just organically grew. If you look at things like Log Analytics workspaces, if you look at Azure Resource Graph, if you look at Defender, they all sit on top of ADX. So this really is just this phenomenal service when I have these logs, I have these metrics, telemetry, and I need to be able to get analysis against it. Azure Data Explorer is the go-to service to enable those scenarios. So that was it. I was going to finish on a little bit of fun. So there is Kusto Detective Agency available. And this is really just a way to start learning all about this. So this detective agency, what I can do is it walks me through key tasks that I need to do. So it walks me through, hey, go and create a cluster. Then, hey, we want you to run these queries. And what you're going to do is basically step through these challenges that it posts to you. I think there's going to be like little badges that's going to be available that can show up in your sort of the Credly and things like that. But it's a great way to just start learning these things. It's free. It's going to use free resources, so it's not going to cost you anything. But it's going to start guiding you through Azure Data Explorer, driving you through Kusto, and just get you to start learning this. So I've got the link to this in the description below. But it's a little bit of fun and help you learn things. And it will just guide you step by step through those various things. So that was it. That's what I wanted to cover. Azure Data Explorer, hopefully you see the value. You understand some of the options, what it's doing, the flexibility of it. As always, till next video, take care.